right, we are starting Unit 10 today. So this is 10.1, and we're looking at right triangle trigonometry. So as a quick reminder, this bell word is to make sure you understand all the logarithms and exponentials we've talked about. See if you can do it on your own. If not, I will once again walk through it to make sure you understand. So on number 1, we have log x plus log of x minus 3 equals 1. We can use our log properties to state that log of x times x minus 3 equals 1. That plus means I can multiply those. Remembering that log with no base is an invisible 10, I can now manipulate this to say 10 to the first equals x times x minus 3. And now I can just start solving for x. So I'm going to distribute. So we're going to get x squared minus 3x. I'm going to minus the 10 over, so 0 equals x squared minus 3x minus 10. This is AC method factorable. We have a negative 10, and we need to find two things that are going to add up to negative 3, and that's going to be negative 5 and 2. So we have x minus 5 times x plus 2 all equal to 0, so x equals 5 and negative 2. Our next thing is we do need to check just to make sure if they work or not. If I plug 5 into any x, we've got positives and logs. If I plug negative 2 into any x, well, they're negative, therefore it doesn't work. So our answer is x equals 5. Number 2, with exponentials, we want to make sure that the exponential is by itself first. We're going to subtract 5 from both sides. We're going to get e to the x plus 1 equals 15. And then I'm going to take ln to both sides, because remember, ln, the natural log, gets rid of the exponential. So I'm going to take ln to both sides. These will cancel. We're going to be left with x plus 1 equal to the natural log of 15. I'm going to subtract 1. But remember, you are not subtracting 1 from the 15. You are subtracting 1 from ln of 15. So make sure you put that in your calculator correctly. This should be in parentheses. So x is going to equal approximately 1.708. Okay, so this is just remembering stuff back from way back when, understanding what we're getting into. But now we're getting into something that's truly important for you guys. A lot of you are either going to be taking trigonometry, calculus, college algebra, anything. Trigonometry is really good because it is very real world applicable, and you really need to make sure this you're good. So 10.1 should be a review of last year's intro to trigonometry that you did, and we're going to get going. Our essential question for today is how are sine, cosine, tangent used to solve problems involving right triangles? So today we're just looking at right triangles, remembering sine, cosine, and tangent. So our vocabulary for today is theta. Theta is this lovely little symbol that's a 0 with a dash in it. It is a variable used to represent an angle. So it's just a placeholder for angles. Sine of theta, if you remember, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? Remember, these though can only be used if theta is an acute angle of a right triangle. So just remember that you can only use sine, cosine, and tangent if it is a small angle of a right triangle. Making sure you remember all that. Okay. Continuing with vocabulary, what is that mnemonic device to remember sine, cosine, and tangent and what they mean? Well, it is so, sine opposite of hypotenuse, cosine adjacent hypotenuse, TOA, tangent opposite adjacent. So that's going to help you if you need to be reminded. Our next and last vocabulary is the most important because a lot of people get these confused. but angles of elevation and depression. This is specifically used in word problems. So these are angles measured from the horizontal line, as you can see from this lovely picture. So we have the angle of depression, which is this angle here, and the angle of elevation for that angle there. It is from the horizontal to the hypotenuse, technically. What you also need to make sure to understand is that the angle of elevation and the angle of depression are equal to each other. So as you can see here in this picture, we have the angle of depression, which is from the horizontal to the triangle. We have the angle of elevation, which is inside of the triangle. They are the exact same degree. So whenever you need to use a right triangle sine, cosine, or tangent, and it says angle of depression, you can say that this angle, since you may know that, is the angle of depression. They are the same thing, okay? So we're going to do 4 examples, trying to get you to remember everything. Hopefully this will help. So a man standing on a cliff, so a cliff, this is our cliff, that is 60 meters high, sees a house, here's your house, at an angle of depression. So angle of depression from the horizontal. See, whenever you have angle of depression, there should be a dotted line. The angle of depression was 12 degrees. Okay, angle of depression has a dotted line, goes to the triangle. How far is the house from the base of the cliff? So we want to know how far is the house from the cliff. Well, we could use certain sine, cosine, or tangent here, but we don't have an angle inside of our right triangle. So again, angle of depression is the exact same thing as your angle of elevation. It should help you a lot. Now that you know what this angle is we have to determine what of the other two given things are we going to use tangent, sine, or cosine. So here we have x, which is adjacent to the angle we're looking at, and we have 60, which is opposite to the angle of the cliff. Okay? So that means we are looking at TOA, opposite over adjacent. So we take tangent of our degree of 12 equal to opposite 60 over our adjacent x. Okay? This is just hopefully a quick reminder. If you're having trouble, please come see me later. But this is just a proportion, meaning this is technically over 1, and we can cross multiply to solve for our missing variable. So we're going to do x times the tangent of 12 is equal to 60, and I'm going to get x by itself by dividing tangent of 12, so we get x equals 60 over tangent of 12, and all I have to do is plug that into my calculator. Make sure your calculator is in degrees, and you should be getting 282.278. Remember, we are dealing with word problems, and we started out with meters, so that means this is in meters. The cliff and the house are 282.278 meters away from each other. Again, make sure if you need help, you let me know. This is hopefully a review. If not, take your time watching this video, please. Okay. So now we're going to be looking at inverses of cosine, sine, and tangent. So when we're looking for specific angles. So we have two. A ladder is 14 feet long and rests against the side of a building. So we've got ourselves a building and a ladder. Need to clean my boards. That is resting against the side of the building. And the ladder is 14 feet long. The base of the ladder rests on the level ground, so base of the ladder and ground, which is 2 feet from the side of the building. So from building to the base of the ladder, this is our ground, is 2 feet. what angle does the ladder form? So ladder to the ground. So we are looking for this missing theta. Okay, so we're looking for this theta, meaning we can still use either sine, cosine, or tangent based off the given information. So we've been given 2 feet and 14 feet. This 2 feet is adjacent to our theta, and this 14 is our hypotenuse, because if you remember, hypotenuse is right across the way from a 90-degree angle. So we have AH, which is the Ka of SOHCAHTOA. So that means we're going to have cosine of our unknown theta equal to the adjacent of 2 feet over the hypotenuse of 14. So we have been given adjacent and hypotenuse. That means we're going to have to be finding the inverse of that, because theta states to get what the missing theta, we take theta inverse of your cosine, so that cosine -1 of 2 over 14. Nothing else changes. If you don't remember how to get to that, it is just second and cosine, so it immediately does it for you. It is in blue right above the original sine, cosine, and tangent. So you put cosine inverse of 2 over 14, and you're going to get that theta is equal to 81.8 degrees. If you are solving for any angles, it is okay to do to 1 decimal. Okay. So we now know from the ladder to the building is 81.8 degrees. So number 3 is very similar. You set up your picture. We have a road that rises 10 feet for every 400 feet along the pavement, not the horizontal. So that means we do have a horizontal here. I need to clean my board, I'm sorry. We have the horizontal here, and it rises 10 feet for every 400 feet of pavement. Again, triangles are probably not drawn to scale. And we want to know what is the measure of the angle the road forms with the horizontal. So we're looking for this lovely theta here. So we've been given 10 feet, which is opposite of the angle, to 400, which is our hypotenuse. So this is our SOH, our SOH. So we're looking at sine. So we have sine of theta is equal to 10 over 400. So that's kind of cool. So again, same thing as the last problem. If you have sine theta equal to an approximate number, to get theta, it is theta sine of the inverse, -1, of the exact same thing you were looking at. So sine inverse of 1 of 10 over 400. So theta is equal to 1.4 degrees. As you can see, triangle is not drawn to scale. Okay. Making sure you remember all of that. We have one more example for these notes, since this is hopefully just a reminder. This one is a little bit of a doozy because you have to find all missing variables. I personally like to go for ones that definitely deal with 20. So I'm probably going to solve for x and w first. So I'm going to look at 40, because this is what's been given to us, and notice that x and w could be used, with 20 being our hypotenuse. X is our adjacent, because it's right next to here, and w is our opposite of this. Obviously, it's going to work for 25 as well, but we'll start with these. So I'm going to solve for w first. I have a 40 degrees, a known hypotenuse, and an unknown opposite. So it looks like we're going to be using sine. So we can say sine of 40 is equal to opposite w over our hypotenuse 20. Once again, this is just a proportion. You cross multiply, and you're going to get w equal to 20 sine of 40. And you plug that in, and w equals 12.856. So that's nice. I'm going to use the same thing, except now I'm going to be solving for x. x's are adjacent, so that means I'm gonna be using cosine. So I have cosine of 40 equal to adjacent of x over hypotenuse of 20. Same process, we cross multiply to get that x equals 20 cosine of 40. So x, when you plug into your calculator, is approximately 15.321. So that gave us w and x, and now we need to find y and z. So those are a little bit interesting to start solving for. We're no longer going to have to deal with 40, but do understand if this is 90, then this degree is also 90. Okay? So we were given 25, so we can look at this degree and we can start solving. But we don't have a given measure. Well, our given measure we technically found. We found what w is. I'm going to actually be using 20 sine of 40 just to have accurate numbers. So I can look at this and see w is opposite to this angle, y is adjacent, and z is your hypotenuse. So now we can use all of our known sine, cosine, and tangents and solve for the missing variables. So I'm going to go for y. So I have a known opposite and an unknown adjacent. So that means I'm using tangent. So I have tangent of 25 has to equal opposite, and I'm going to be using 20 sine 40 just for accuracy over our adjacent y. Now that we've done that, this is again still a proportion, so you're going to cross multiply. You're going to get y tangent of 25 equal to 20 sine of 40, and then you're just going to divide by tangent of 25. So y equals 20 sine of 40 divided by tangent of 25, so y equals 27.569. We just have one more variable to solve and we're done. So we're going to solve for z. I'm still going to use w instead of y because I don't want to plug that in. I'm going to use the easier one. So I'm going to go over here and I'm going to see that I know my opposite and I know my hypotenuse. So this is our so sine. So we have sine of 25 is equal to our opposite, which is our 20 sine of 40, all over our unknown z. Okay? We're going to cross multiply to see that z times sine of 25 equals 20 sine of 40. We're going to divide by sine of 25, so z equals 20 sine of 40 divided by sine of 25. We plug that in your calculator. As a quick reminder, I didn't say it over here, you should be putting the numerator in its parentheses so that it doesn't confuse itself. And you should get z to be 30.419. Hopefully this was just a quick refresher and you understood all of the sine, cosine, and tangent possibilities. But please, if you are struggling, let me know so I can make sure that you get this, because this is very much trigonometry at its finest. This is what we're doing for the rest of the unit.